All right, we are starting on 4.3. We're going to take 3 days. The reason is, for me, it's very confusing is that we have to be able to draw f prime or f double prime given any kind of situation. So it's kind of crazy. For example, they could give you f prime and then you have to figure out how f double prime looks like and f and things like that. So we'll get better, but you'll probably get better than I am. I'm just kind of forever stuck. Very confused. Okay, so first thing, f of x looks like this. So go ahead and draw this on your notes. So notice that there are some interesting points. There are 5, A, B, C, D, E. A and E are the 2 endpoints. B and D are the highest and the lowest, or not really the highest, the local max and local min. And then C is a point between B and D, and it's special, but I will tell you why later. Okay, so draw f of x. So now what you're going to do is draw what you think f prime and f double prime looks like. So you might want to do it in pencil if you're not super sure. That way you can erase a letter later, and then I can show you how it should look like. So go ahead and draw what you think f prime looks like and f double prime. So the derivative, remember derivative means slope, so you're graphing a slope of this function. All right, let's do this. I'm going to draw on top of f of x, so it's easy to see. Okay, so remember you're looking at the derivative, which means the slope. The points that are of interest are probably the ones that's on the top and bottom, so the max and minimum, right? Those are nice, easy points to figure out the derivative. So what is the derivative at b and d? 0. So my derivative is going to have a 0 on those 2 points. Okay, next, let's look at the other parts. So this part between A and B, what is the slope between A and B? Positive, right? So the thing is, it was really positive, and then it kind of slopes down to less positive until it gets to 0, right? Very positive on a derivative graph means very high up here. So the value of the slope is very high, and then it goes down to 0. What happens between B and D?
It goes negative.
It goes negative, right? It started with very shallow, so less negative, and then it goes down to very negative, right? So like this, right? And then at D, it's 0, right? But my graph has to connect. It can't just jump like this, right? You know, it's a continuous graph and it's smooth. We know the derivative has to be also smooth. So what happened? It has to go back to 0, right? So somehow it went back. Okay, for me, that is the hardest thing to see, that, oh, it's negative, why did it go back up? Okay, so you can see here, it was not as, at B, it's 0, and then it got a little negative, and then got very negative, and then here it comes back to not as negative, which means it's almost at 0. Okay, between D and E, what's the slope? Positive, so we're going to go up. Something like that. Okay, something like that. So this is my f prime graph. Okay, f double prime. So basically do it again. So look at the blue graph and then graph the f double prime. So what are the point of interest? C, right? Okay, so there's a reason I drew C there. C is going to be the absolute minimum for derivative graph. So this point, I'm going to put a different color. It's going to be 0 here. And if you look at the blue graph, just the blue graph, On the left of C is what kind of slope? Do you need your... Okay, put it away. Okay, so on the left of C, what kind of slope is it? Is it negative or positive?
Negative.
Negative. So that means my slope is on the bottom, the negative part of y. Okay, negative values. And then after C, to the right, between C and E, we're again looking at the blue graph. What kind of slope is it? Positive slope, so it's going to go up. Okay, so this is my F double prime graph. Yeah.
How do you know the critical point is definitely
You don't. That's why, no, for now, I'm just giving you C. Yeah, demonstrate, but you'll have to find it later. Okay, let's look at how we can draw this better. So what you want to do is from the first graph, from the red graph, what you want to do is, again, find the critical points, right? The critical points are the maximum and minimum. So what makes the derivative 0 or undefined? That's a critical point. So from the critical point, you're going to draw a sign chart. You put the critical points on the sign chart. So these are my critical points. And what you're doing on the sign chart is you're asking yourself from the red graph, am I increasing or decreasing? Okay, for example. So everyone just tune out blue and green, okay? Only look at red. So from the red graph, you can see that B and D are going to be zeros, right? So those are my critical points. And then you look at the slope. So on the left, increasing, decreasing, increasing. Okay, so that means plus, minus, plus. So then when you do the derivative graph, you can see that this part's going to, when it says plus, it's above the x-axis. When it says minus, it's below the x-axis. Okay? And then we can do the same thing with the second derivative, yeah. So this is going to be at C. Again, we take a look at the blue graph for the green. So we look at the derivative, first derivative for the second derivative. You always look at the one before that. Okay, so at C, it's going to be 0 for the blue graph. And then you can see the graph is going to go down and then up. So that's going to be minus and plus. So that means on the green graph, left of C is going to be negative and then right of C is positive. Okay, quick rundown. Now we're going to take it a little slower and actually go through everything. Okay, first thing, we have this increasing, decreasing test. So when we're talking about increasing, decreasing, and later with other stuff, we're always talking about F. We're trying to analyze F by looking at F prime, F double prime. But all of these increasing, decreasing, we are talking about the first graph, the f of x. Okay, so if f prime is greater than 0, then f of x is increasing on that interval. If the derivative is positive, then you're increasing. Basically, your slope is positive. Okay. If f prime of x is greater than 0 on the interval, then f of x is increasing on that interval. Same thing. If f prime of x is less than 0 on the interval, then f of x is decreasing on that interval. Okay, you use the derivative to check if it's positive or negative to see if it's increasing or decreasing. Okay, let's look at something more closely. If f of x is increasing in a to b, does that mean f prime of x is greater than 0 for all x in a to b? Okay, if f of x is increasing, it looks like it's increasing all the time. Does that mean the derivative is always positive? No. So one person said no.
Yes.
Yes. No. Is it always positive?
Not always positive, it's just increasing.
Right, so if the graph looks like it's always increasing, does the derivative have to be positive?
Yes.
No.
No, not at all.
No, because if the graph looks something like this, and then there's actually a horizontal tangent here, then that point is 0. It's not positive. Okay, so like x cubed graph. It's always increasing. You would think the derivative is always positive, but not true. At one point, it's going to be 0 and then go up again. Okay, so just kind of special situation. Next, if derivative is greater than 0 on a and b, is there a local or absolute extrema? If the derivative is positive, is there a local or absolute extrema?
No.
Okay, talk to your partner. If the derivative is positive, between a and b, is there a local or absolute extrema? What does it mean when it's positive? What does it mean when the derivative is positive?
This is not open. I'm closing
Should we be writing this down, or at least this part down?
If you want. So it's kind of like, I mean, you can deduce all this stuff on your own if you want.
No, there isn't.
This is
Well,
not
if it's
including
positive from everything.
Local or absolute maximum.
Okay, let's vote.
But then it's not.
If the derivative is positive on a and b, is there a local or absolute extrema? Raise your hand if you say yes. Raise your hand if you say no. Okay, why not?
Because it's not close into.
Because the local or absolute extrema require the f prime to be 0. Well,
Okay, that too.
This is not including B.
No, local extrema is always open interval. And an absolute could be local if it's at a point. Okay, so basically, no. Yes, you're right. No. And kind of like Jonathan said, that's one reason. It has to be 0 somewhere. Also, it has to change direction. To have an absolute anything or any kind of extrema, you got to change direction. You got to go up and then down, or down and then up. If it's always positive, then there's no turn.
But there's still
There
could
could
be an
be, there's a
absolute.
local.
No, it's an open interval, so it's not possible.
Oh.
Okay, next. If f prime is greater than 0 on a and b, and f prime is less than 0 on b and c, is there a relative maximum at x equals b? Okay, talk to your partner again. Between a and b, it's increasing. Between b and c, it's decreasing. Is there a relative maximum at b? All right, what do you guys think? Is there one? Yes, there is a relative maximum. No, there's not a relative maximum. We don't know. Okay, so we know that at A, B, and C, there's some possible direction changes. So between A and B, it's positive, and then between B and C, it's negative. So that means we went up and then we went down. The question is, at B, is there a top point? I say we don't know, because unless it's continuous, then we don't know if that point is
It doesn't
maximum.
need to be continuous.
Well, it's either like this, or like this, or like this, right? So the second one, there's nothing, right? We kind of went over that. The third one, there is an absolute maximum. The first one, there's an absolute maximum. So we don't know. Okay, next one. If f prime is greater than 0 on a and b, is f continuous on a and b? Should be easier. Okay, talk to your partner. This is kind of the very important thing from chapter 3 at the beginning.
Yes, if those discontinuities, there would be no, well, it would be undefined at a point, but it says it's positive on all points within the intervals.
Okay, so how many people think, yes, it is continuous? How many people say, no, it's not continuous? How many people say, I don't know, it could be discontinuous? All right, it has to be continuous. Why? Because derivative means it's continuous. Okay, differentiability implies continuity. If you have a derivative, you must be continuous. Okay. Okay, I think we can skip this part and let's go to solve some problems. Okay, for this function, find the interval where it is increasing or decreasing, and then find the relative maximum and minimum and justify your answer. So we need to learn how to justify our answers the way AP wants us to do it. Okay, first, we want to figure out where it's increasing or decreasing. That means all those increasing, decreasing, maximum, minimum, they all mean derivative. Okay, so we got to find derivative. 12x cubed minus 12x squared minus 24x equals 0. All right, so go ahead and find the critical points, and then we'll come back together and do maximum, minimum, and increasing, decreasing. Okay, where are my critical points?
0, 0,
Yes. Okay, once you have the critical points, what you're going to do is you're going to draw a sign chart. So remember from last year, and make sure they're in order. The gap or the distance between them doesn't really matter. And I would label this as well, f prime of x, because we're going to do another sign chart for f double prime, and you don't want to be confused. And what you're going to do is put the sign for each interval. So kind of like last year, what you're going to do is find numbers in between the interval that you can check. So for example, numbers that's smaller than -1, so maybe check -2. Between -1 and 0, so maybe -0.5. Between 0 and 2, probably check 1. And then numbers bigger than 2, 3. Okay, that's one way to do it. Not the fastest way, because this polynomial is very easy. It's just a polynomial. When it gets really hard, it's crazy stuff, then you can do this. We can see that this is just third degree, right? How does third degrees always look like? Like that, right? So it's going to be negative, positive, negative, positive. Yeah, so then you can just put it in because it's just a normal third degree. And each 0 only happened once, so there's no bounce. You guys still remember from last year, right? Okay, there's no multiplicity issues. All of them are odd multiplicity, so they all cross, so it's just easy stuff. Okay, so when it's easy like this, just do it. Don't use the calculator, or else it's going to take you too long. Okay, so the question is, where is it increasing or decreasing? Well, that's going to be easy. Increasing is from -1 to 0, and then 2 to infinity. Right, just all the ones with a plus. And then decreasing is from -infinity to -1, and then 0 to 2. Okay, this one's a little bit tricky. especially when we get to second derivative. So increasing, decreasing, a lot of textbooks and mathematicians have a lot of debates. But for now, we're going to say increasing, decreasing, you want to include the endpoints, so closed interval. But there will be people saying, why do you need to include it? Yes, and then they have different reasons. So for now, the book says included, so we're just going to include it. So closed interval. Unless it's an asymptote or discontinuity, then obviously don't include it. Does that make sense? You never include a hole, right? You never include an asymptote. So if it's continuous on that point, then just include it. Okay, next. So that was A. B. Find the relative maximum and minimum and justify your answer. All right, so here's what you're going to do. From this sign chart, if it's negative, you're going to draw decreasing. If it's positive, you're going to draw increasing. So decreasing, increasing, decreasing, increasing. And that's how the graph is really going to look like. It's going to go down and then up and then down and then up. So where is the relative maximum? At x equals what? 0. Yeah, because it goes up and then down. So you can see the graph has to be like this. So at 0, it's going to be a relative maximum. At x equals 0. And if they want the actual point, then you had to put it in. So 0 and then 5. So I put 0 into the original function. And I'm going to leave a space here because I'm going to write justification. But before that, let's just finish this problem with the relative min. Where is the relative minimum?
Negative 1 and 2.
Negative 1 and 2. So you can see it goes down and up, down and up. So that's going to be the relative min. So negative 1 and then 2. And let's find those numbers. 0 and negative 27. All right, most important part, justification. How do you know that it's a maximum? And all of you answered on WSQ correctly. How did you know it's a maximum?
The maximum from the left side is positive and the right side is negative. Derivative.
Yeah, right. So it changed. So all you have to do is say it changed sign from positive to negative. Okay, so let's write this down. If C is a critical number of a continuous function f. If C is a critical number of a continuous function f. If f prime changes from positive to negative at C, then f has a local maximum at C. So that's your justification. So someone asks you, how did you know that this is a local max? You say, oh, because f prime changes from positive to negative at x equals blah. Okay, same thing. How did you know that this point is a local min? Okay, then you'll say that f prime changes from negative to positive at C. Okay, what if the sign doesn't change? Goes from positive to positive.
Then bounce.
Not bounce, it just kind of stopped and then went up,
Oh.
right? So like x cubed. Increase, 0, increase. Yeah, so like x cubed increase, 0 increase. So that's basically when you draw the sign chart, it's going to say plus, plus. Or when you draw the sign chart, it's minus, minus, so it went down and down. Okay, so that's the third one. If f prime is positive to both left and right at C, or negative to both left and right at C, then f has neither a local max or local min. So if the sign doesn't change, then you don't have a local max or min. The direction has to change.
Isn't it like bounds?
No, bounds for the derivative. The original function is just continue going. All right, anyways, so we need to write that justification every time someone asks you, justify, how did you know? We gotta write that. Okay, so let's practice. Very easy, continuous function. So find the interval which is increasing or decreasing, that tells you first derivative. And then find the relative maximum minimum, again, first derivative question. So go ahead and do that. Where are you increasing, decreasing, and where the maximum minimum, and justify. What did you guys get for the sign chart? All positive? No. Negative, positive, negative, positive. So you can write your increasing, decreasing. Okay, and then from that sign chart, you kind of want to just draw this decreasing, increasing, decreasing, increasing, and then from there you can tell what's going to be relative min and what's relative max. Make sure you write the justification. So for example, there is a relative min at negative x equals negative 1. How do you know? How do you know there is a relative min at x equals negative 1? Someone say something. No? What? How do you know there's a relative min at x equals negative 1?
Which is negative to positive. Negative positive.
So f prime changes sign from negative to positive. Okay, that's what they're looking for. F prime changes sign from negative to positive.